Today, we're going to use lines of best fit to analyze some data. The context here gives us some information about shoe sizes and men's height. I'm going to go ahead and predict that there's probably a fairly strong positive correlation, meaning this data is going to look like a line because you would expect that men with bigger shoe sizes are probably a little bit taller, or men that are a little bit taller would wear bigger shoe sizes. I'm going to go ahead and label the axes based on the categories of data, which are shoe size and height. Now I want to scale them so that there's a window where all the data fits. So for the shoe size, the smallest value looks here that it's going to be 8, and the highest value looks like it's going to be right next to it at 13. Because I'm scaling it, I need to know how much room I have on the graph to scale it. I know that I'm going to break this data up. So I'm going to start here and I'm going to count how many positions I have available. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the difference between 8 and 13 is 5. I also see that I have 8.5s, or half shoe sizes. Therefore, I'm going to actually have room for those halves. I'm now going to do the same thing for the height. So now we can go ahead and plot our coordinates. Lastly, I'm going to draw a best fit line. I'm going to try to find a line that goes through these points that kind of splits the difference between all the points. I think this line between these 2 points might do it. To do anything with this line of best fit, I need to have an equation. Okay, we can now use this line to complete the rest of the problems. So the first question says to use our line to determine if a man had a shoe size of 10.5, what would you predict his height to be? Now we could use the graph over here to figure that out. So if I had somebody at 10.5, I would say that the line here looks like they might be 71.75 inches high. So let's go ahead and use our equation to do that. It's good to keep in mind what our variables stand for. X is shoe size, and Y is the man's height. So if I want to find the man's height with a shoe size of 10.5, I just plug in 10.5 to X and solve for Y. Note that this value is pretty close to our prediction. So we would say that if a man has a shoe size of 10.5, we would predict that he had a height of 71.6. We could also work the other way. So if we knew what a man's height was, we could figure out his shoe size. Notice we can't use a graph to do this one because 80 inches tall is past the range of our graph. So I'm going to rely solely on the equation of the line, and I'm going to do the work here. So this is the same equation we had before, but because I'm given the height and I want to find the shoe size, I'm going to plug 80 into Y. So what we could say is that if a man were 80 inches tall, that's roughly 6 feet 8 inches, that man might have a shoe size of 16.5. Alright, so go ahead and try assignment number 9. If you have any questions, please contact me or your other Course 3 teacher.